Hello everyone, welcome to the Mathematics MI channel. In this video, we are going to solve this nice integral from 0 to 1 natural log of x times arctan of x dx. Well, what do you think? How to evaluate this integral? Okay, first, I'm going to introduce another integral. So I'm going to take f of alpha is equal to integral from 0 to 1 x to the alpha times arctan of x dx. Then I'm going to differentiate both sides with respect to alpha. So here we know f dash of alpha is equal to integral from 0 to 1. Now here x to the alpha times natural log of x times arctan of x dx. Then if we plug in 0 here, f dash of 0, now we know f dash of 0 is equal to integral from 0 to 1. Now x to the 0 power we know 1, so we have again I, we know natural log of x times arctan of x dx. So this integral is equal to I. So if we evaluate f dash of 0, we know we already evaluate I. So now let's evaluate f dash of 0. Therefore let's take again f of alpha. We know f of alpha is equal to integral from 0 to 1 x to the alpha times arctan of x dx. Then I am going to use the Taylor series of arctan of x. So we can write here integral from 0 to 1 sum of n is equal 0 to infinity minus 1 to the n over 2n plus 1 times x to the 2n plus 1 here, but we have x to the alpha, so we have x to the 2n plus 1 plus alpha, and here dx. Okay, then we can switch the integral sign and sigma notation. So we have n is equal 0 to infinity here. Now we know minus 1 to the n over 2n plus 1. Then we have to integrate x to the 2n plus 1 plus alpha. So we can use the general power rule of integration. So we have x to the 2n plus 2 plus alpha over 2n plus 2 plus alpha, but we know the limit here 0 to 1. Okay, now if we apply limit, now we have sum of n is equal 0 to infinity minus 1 to the n over 2n plus 1. If we plug in upper limit 1, we know we have 1 over 2n plus 2 plus alpha. 2n plus 2 plus alpha. Well, then what's the next step? Yeah, it's clearly we know now partial fraction decomposition. So we know we have we can use a cover method. So generally we know we have 1 over alpha plus 1 times sum of n is equal 0 to infinity minus 1 to the n over 2n plus 1 minus 1 over alpha plus 1 sum of n is equal 0 to infinity. Now here minus 1 to the n over 2n plus 2 plus alpha. Well, here this sum familiar with us because we know about Dirichlet beta function. Beta of s is equal to sum of n is equal 0 to infinity minus 1 to the n over 2n plus 1 raised to the s power. So this is equal to beta of 1, and beta of 1 we know pi over 4. So we have here pi over 4 times 1 over alpha plus 1 minus, here we have 1 over alpha plus 1 times sum of n is equal 0 to infinity minus 1 to the n over 2n plus 2 plus alpha. Well, now we know this is equal to here f of alpha. So this is, we know, f of alpha. Then I'm going to differentiate with respect to alpha. So we have here f dash of alpha is equal to, now we know we should integrate 1 over alpha plus 1. So we know minus pi over 4 times 1 over alpha plus 1 perfect square. Then here minus, so minus, then parentheses. Then here 1 over alpha plus 1, and this part we know we have product of two functions, so we should apply product rule of differentiation. So here now I'm going to rewrite first 1 over alpha plus 1, then we should differentiate second function, so n is equal 0 to infinity. Now minus 1 to the n power over 2n plus 2 plus alpha perfect square, then plus again we should rewrite then first function, sorry, second function, and we should differentiate first function. So we have minus 1 over alpha plus 1 perfect square, sum of n is equal 0 to infinity minus 1 to the n over 2n plus 2 plus alpha. Okay, then we know we can apply 0. So f dash of 0 is equal to here only minus pi over 4. Then here we know minus, here minus, so plus n is equal 0 to infinity. Now we have minus 1 to the n over 2n plus 2 perfect square, then plus sum of n is equal 0 to infinity minus 1 to the n over 2n plus 2. Okay, now I think almost we are done, because here minus 5 over 4, then this sum we can write 1 over 8 theta of 2, and here we know 1/2 natural log of 2, then theta of 2 5 square over 6, so we have 5 square over 48 plus 1/2 natural log of 2 minus pi over 4. Okay, this is the answer for this integral, because we know f dash of 0 is equal to I. So if you like this type of videos, please subscribe this channel. Thank you for watching.